Hello and welcome to my presentation about multi-sensor investigation of landslides triggered by 2019 extreme rainfall events in Golestan province, northern Iran. My name is Mahdi. I'm from Geosciences German Research Center for Geosciences and Leibniz University, Hanover in Germany. Between mid-March and at the beginning of April 2019, almost the whole Iran was affected by intense record rainfall, leading to widespread flooding in the country. The event affected approximately 10 million people, among them 2 million in humanitarian need. In this presentation, we focus on Golestan province in the north, which in addition to flood was heavily affected by landslides. The initial landslide inventory compiled by local authorities based on field visit or local reports indicated more than 400 events in the region. Such point-based landslide inventories, also very valuable information, often are not very accurate for two obvious reasons. Firstly, they are biased towards accessible areas like those events occurred close to roads. Secondly, they are point-based information and cannot illustrate the true dimension and extent of individual landslides. At GFZ, we have developed a system for automatic detection of landslide as objects using remote sensing observations. Our system exploits multi-sensor time series of optical satellite images, analyzes changes in normalized difference vegetation index, and then detect landslides as objects and polygons instead of points. Such information can help us better understand the processes involved and evaluate landslide hazard at risk at regional scales. At selected hotspots, we have also assessed the kinematics of pre- and post-failure slope motions using radar remote sensing observations. This has been shown, for example, for Kalpush landslide at the border between Golestan province and its neighboring province Semnan in the south. The motion of this landslide is clearly visible when we compare two high-resolution satellite images from Planet Labs imagery over these regions. The motion on this landslide caused widespread damage in the village nearby and destroyed more than 200 houses. Long-term slope motion monitoring using data from Sentinel-1 indicates that this landslide was active before and was showing signs of instability already since 2014. So it was not surprising that it ultimately failed in response to external triggering factors. We are now investigating the role of different climatic and non-climatic factors on influencing the kinematics of such landslides in the region. Thank you very much for your attention.